Starting from the idea of a rational agent, in which the goal is the maximization or minimization of some metric, when we compare an agent with humans, we can distinguish 5 cases, depending on how agent performs with respect to humans. We say that the agent is optimal when it is not possible to perform better. An agent is superhuman when it performs better than all humans. Is high human when the agent performs better than most humans. Is parhuman when the agent performs similarly to most humans. And finally, is subhuman when the agent performs worse than most humans. Remember that according to the narrow AI approach, a rational agent is developed to address a specific problem. What we can do is to give a picture of the capabilities of the best AI techniques for every specific problem, and we can monitor the progresses of the AI technique during time. Now we provide some examples. Almost all the problems that we can solve with optimal, superhuman and high human agents are well structured and can be easily described in terms of mathematical tools. For instance, we have optimal AI agents for tic-tac-toe. Notice that this game can be played optimal or even by humans. Conet 4, checkers, Rubik's Cube, heads-up limit, and hold'em poker. Notice that a poker game is a stochastic game in which the outcome depends on the cards each player draws. Optimal play in these games means that if a game is repeated a very large number of times, there is no way of getting a larger value. When the performances are not optimal but better than most humans, we can have superhuman agents. This is the case of Othello, Scrabble, Backgammon, Jeopardy, Go, heads-up no-limit hold'em poker, 6-player no-limit hold'em poker, chess. Remember that in 1966, one of the first AI artifacts was exactly a chessbot with subhuman capabilities. Notice that in these cases, we can imagine new agents stronger than those available today, but it is unlikely that human beings will beat these agents in future. Then we have problems that the best AI agents can face as well as high humans. For instance, for crosswords, Dota 2, bridge card playing, StarCraft. When moving to par or subhuman, we observe that the problems have some form of connection with perception or physical actuation. For instance, for parhuman, optical character recognition, classification of images, handwriting recognition, and for subhuman, optical character recognition for printed text, object recognition, facial recognition, stable bipedal locomotion, speech recognition. The evolution of the techniques and of the computational capabilities of the machine make the performance of AI agent increase. However, there is no guarantee that for a problem that we can address today with, for instance, subhuman performance, we will solve tomorrow with parhuman or high human performances. That is, we can imagine that for some problems we could not design even in future agents better than humans.